Hello everyone, my name is Remi Duquette. It is an honor to be a keynote speaker at this year's ASEE conference. Now, because of the current world pandemic, you are all at home, and I felt it would be appropriate for me to welcome you from my favorite spot overlooking Montreal, my hometown, where we were all supposed to meet in person. So here is a little flyby from my little drone this morning. Without further ado, the main topic of my keynote address today will be focused on the future of work from an engineering viewpoint. Again, my name is Remi Duquette. I'm currently Vice President of Innovation at Maya HDB Technologies, based in Montreal, and where I worked for almost 20 years now. I have worked on 5 satellites currently orbiting the planet. I spent over 1,000 of hours building machine learning algorithms and building AI infrastructure, and spent over 10,000 hours on skates since childhood. I love to collaborate with academic professors like you are all on the phone today and students on innovative ideas, so don't hesitate to reach out. After over 35 years in business, we at Maya HDB pride ourselves to be #1 engineering simulation company in Canada. We are hundreds of passionate engineers and scientists building CAD, CAM, CAE, PLM, and industrial AI solutions for many diverse clients. Many of us at the company started in the space industry, like I said before, myself with 5 satellites currently orbiting the planet, and we diversified our portfolio to automotive, manufacturing, marine, energy, and many other industries over the years. We now offer over 30 solutions and have been awarded this year #1 worldwide partner at Siemens amongst thousands of partners, which is quite an interesting feat for us. Back to our topic of the future of work. It is always nice to look back in the rearview mirror before we try to look into the future. Since I left academia 20 years ago now, many engineering feats were achieved, such as the ability to edit DNA, discovery of the Higgs boson, the successful landing of and missions of many rovers on Mars, quantum supremacy recently, reuse of rockets to get back to the International Space Station, self-driving car, artificial intelligence. I mean, the list goes on and on. And if this was a multiple choice question back 20 years ago, I think we would have probably all failed to predict that all of these would be true today as we speak. So now let me focus on AI, given I would suggest this has the biggest potential to change the future of work for engineers moving forward. First, we have gone from being nowhere near human level visual perception back in 2010 to having deep convolutional neural networks being more accurate than most humans over the last 5 years alone. In a similar way, natural language processing has also become close to human level accuracy, not quite yet. And while it is still, a little bit away from human quality, some AI chatbots can hold decent conversations in over 100 languages. We can be critical, of course, of all the chatbot failures we have seen in the media, and so should we be critical. But we are forced to admit that this is a pretty spectacular achievement in recent years. On a more, let's say, deeper level, so if we dive a little deeper, we all remember Deep Blue beating Garry Kasparov in '97, which itself was a great feat, but it was brute force computing. 20 years later, in 2017, we now have a major paradigm shift where software programmed by human beings based on logic are beginning to be surpassed by AI algorithms, which learns from self-play and can destroy other software programmed by human beings, such as Stockfish since 2004. And that's, with only 4 hours of deep learning or reinforcement learning. through self-play, which I love. Don't get me wrong, I love playing chess and I love learning with stockfish. But this is quite a paradigm shift, and we all need to pay attention to it. On a more practical and engineering aspect of AI, we can now apply these new deep reinforcement learning algorithms to learn to control the cooling plant of a data center, for instance. Here you can see that we can build an AIMSIM system-level model to be played with by an AI agent and to learn to achieve the initial learning and capturing the complexity of nonlinear control sequences without ever programming a single PLC controller. And given the AIMSIM model was built here to represent the reality of a high-fidelity Siemens SimCenter 3D flow model, the AI agent can surpass any other rule-based system or control and save a ton of energy and reduce carbon footprint for data centers. As another example from our friends at Siemens, they recently released an AI tech within a 2D CAD sketching, and which can reduce up to 30% of the time spent by designers in their sketching tasks. When you think of a 40-year-old technology such as sketching, getting a boost from AI today in 2020, I don't think you can find much better example of how AI is changing already our world and our habits as engineers. Now, all this ties back to our topic of the future engineer. As engineering faculty professors, you all get to inspire the future engineers enrolled at your schools like you did for me way back when. And as an industrial partner now, I can only provide you with some of the trends we see and which need perhaps to be taken into account. I think we are all good on the hard skills taught in engineering schools. Based on the rise of new tech such as AI and or quantum computing, we will increasingly need engineers to have better soft skills, if only so they can translate the complexity of new systems behavior. Now, I do recognize that teaching and measuring hard skills is relatively easy, while teaching and measuring soft skills is not. So, you'll have to consider that in moving forward. As I was preparing myself, a colleague asked me if I thought we should focus on hiring a highly specialized engineer or a jack of all trades, kind of a general purpose engineer. I hesitated a lot, as from a business standpoint, if you over-specialize, you clearly will be much better on day one. But with this world pandemic and new AI tech and quantum computers rising or on the horizon, I am slowly thinking that someone perhaps with better fundamental and general knowledge base might be more resilient over time. I can't really test this hypothesis, of course, so I will let you figure out this tug of war between specialization and generalization in your teaching. But just food for thought from a recent future of work study, largely because of the pace of technological changes like AI and other things are bringing to bear, the future engineer might hold or is likely to hold more than 7 different jobs over a lifetime. It might be worth considering how to adapt to this future reality from an academic and industrial collaboration viewpoint. While it used to take a lifetime to become a craftsman, or as some of people mention, 10,000 hours on any given task to become a real craftsman, or at least an expert level. Now, we need to augment ourselves through continuous upskills programs combined with smart use of new human enabling and augmenting technologies such as AI, chatbots, and other. And there again, students will likely need more continuous education programs than ever. And it will be increasingly important to collaborate now more than ever between industry and academia to stay in closer sync with each other as things just continuously change on the outside world. And we both depend on it. As I like to say, once you stop learning, you start dying, and that might be increasingly relevant moving forward. I'm not going to just paraphrase Einstein, but I think it is especially true these days. Now, as we come to the end of my presentation, I wanted to highlight that the future engineer shall really not look or act like a robot, but rather um, being ethical and caring and capable of augmenting himself or herself through smart use of AI and robotic technologies. Collaboration, I believe, between human and AI and chatbots and physical robots will be a strong industrial vector influencing the future engineer. And so we should think about this in the curriculum and in the way you carry out your courses and your learning curriculum. Of course, I encourage you to leverage industry partners like Maya Heat Transfer Technologies and Siemens to help teach the concepts and tools in the classroom. And of course, if you have keen and smart students, please send them our way, and you can send them to our Maya Ingenious Trivia Challenge. And if you would like to collaborate on any CAD, CAM, CA, PLM, or AI innovations, please do not hesitate to contact me. It would be a pleasure to continue the conversation. On that final note, I hope you enjoyed your virtual Montreal experience, and I look forward to answering some of your questions. Let me just send you on a short second ride with my little drone.